Hello and welcome to this session. Today's session will discuss the essential maths for multivariate data. So when we are talking about machine learning, it's very important that you do have some good knowledge about math, especially linear algebra, statistics, probability and information theory. So you might have studied linear algebra in your math classes. Basically, it's a branch of math which is used in many scientific applications and in ML, that is machine learning. And linear algebra, when I say, it should come to your mind that it deals with linear equations, right? Where we will have to deal with vectors, matrices, vector spaces and transformations. Now let's try to understand linear systems and Gaussian elimination for multivariate data. Since we have started in the previous session, we have discussed about multivariate data. Basically, it will have multiple variables. We saw univariate data, which has just single variable. Bivariate will have two variables. Most of the machine learning problems will have lot of variables, right? So it's normally a multivariate data that we have in machine learning. So it's very important that we solve this multivariate data with linear systems of equations, and that's why linear algebra is very important when you are working with machine learning. Now, what is linear system of equations? Linear system of equations is nothing but a group of equations with unknown variables. So let's say ax is equal to y. I need to find x. So how do you find? X is equal to y by a, which is nothing but a inverse of y. Let's say this is equation 1. Now this equation will be true only if y is not equal to 0 as well as a is not equal to 0. Now, generally speaking, the equation will not be simple. It will be a n set of equations with n unknown variables. We have a is equal to some n matrix with these other values, and y is equal to y1, y2 up to yn. Now we need to find unknown variable x. Now that can be computed as x is equal to y by a or a inverse of y. So the question is, we need to find x. X is a unknown value. Now there are three types of solutions that we can obtain for x. Either we can get a consistent independent solution, we can get a consistent dependent solution, or we can get an inconsistent solution. Consistent independent means if there is a unique solution. If x has just one unique value, we call it as a consistent independent solution. If we have if we have various solutions, more than one value for x, we call it as a consistent dependent. Inconsistent if there are no solutions. Sometimes it's possible that x will not have any solution. We call it as no solution, and in this case the equations are inconsistent or contradictory. Now normally we will have large number of equations, and the best method is to use Gaussian elimination method. So let's just look into the procedure for applying Gaussian elimination. Now this is very similar to what you have done learned in your math class. This is a simple procedure. First you have to write down the matrix, reduce the matrix to the augmentation matrix. Augmentation matrix is a matrix where it will consist of coefficients of the variables and constants. Then we will take the first element in the row in the matrix, that is A11, which would be, we call it as a pivot. Then we will do a lot of row matrix operations so as to reduce the matrix to a reduced echelon form. How to reduce echelon form, I've done a video in the next session. And then finally we are going to find x. So this point is called as a backward substitution, and to facilitate this application of Gaussian elimination method, that means to reduce it to a row to a reduced echelon form, you might have to do a lot of row transformations. And all these are possible operations that you can do. You can do swapping of the rows, that is allowed. You can multiply or divide your row by a constant. You can replace a row by adding or subtracting it or multiplying it with another row to it. So these are the three possible operations that you can do on the rows of your matrix in order to reduce it to a reduced echelon form. In the next session, we will see a problem on this using Gaussian elimination method. Thank you so much.